This bridge failed because of a half-inch design error which caused 13 fatalities and led to over 100 injuries. So this is the I-35 West Bridge in Mississippi, and it was actually opened back in 1967 and ended up collapsing back in 2007, which means it only had a service life of 39 years. And as you can see, it's a pretty good looking truss bridge, and the failure was actually in the truss, but what was the actual cause? To understand the failure, we first need to understand how trusses work a little bit. So here's a close-up of a different truss utilizing the same system. And as you can see, there's a lot of these members all connecting to this one little plate down here. That's what we call a gusset plate, and that's what helps transfer the forces and stresses throughout the entire truss to help balance everything out. On the I-35 West Bridge, the gusset plate connections were actually only half an inch when the design was supposed to call for an inch. As you can see, there's already a little bit of deformation forming in the gusset plate, but it wasn't anything too critical that they picked up in inspection, so they were just planning to run with it for now and eventually reconstruct a new bridge at a later time. But because of that, when the bridge was loaded in rush hour traffic back in 2007, the gusset plate ended up failing, wasn't able to transfer any forces to the remainder of the truss, and since there was no redundancy, the whole bridge ended up collapsing like a domino effect and leading to this disaster here. Now you might be asking yourself, if the gusset plate was only half of what it should have been, why did this collapse take 40 years to happen? To answer that question, we're going to be looking in the AASHTO LRFD Bridge Design Code, which gives us all the requirements we need to meet when we're actually designing a bridge. So in the code, we have what we call load combinations, which are basically there to scale up the loads that we're expecting to see to make sure we're accounting for any uncertainties in the design. An example of this is that the strength 1 load combination has a load factor of 1.75 for vehicle loads. So whatever vehicle loads they were designing for, they basically doubled it and then made sure their connections were strong enough to handle that. So since our bridge design codes are so strict, it's more likely that the cause of the collapse was due to a couple reasons, such as the high loads the bridge saw that day, obviously the under-designed gusset plate, and the fatigue that caused the gusset plate to reduce in strength over 40 years.